See? It's like that, right? So you say, in my opinion, whenever I prepare the calendar, then I just check the days of the saint, right? The saint, especially, it falls in either Ashwin or sometimes Kartik. But very soon, Gadasavana comes. Then when Gadasavana comes, immediately after few days, Dasai, Vijaya Dasai, and Kojagat Purnima, Dasai, their vacation over, school restarts. So time is like that, no? Time just goes very quickly. But we don't just prepare accordingly. Like today is 10th of Ashadh. This day is also gone. What's the time now? It's 15:41 already. After some time, 4:30, this class will be over. And next social studies. Then after 1 hour, again class over. Then you go home, this and that. 1 hour and 40 minutes. No, even though time is like that, no? So the people who can manage their schedule according to time, they can do better. Otherwise, they cannot. And great changes they occurred in Anubhav as well, right? Earlier, teacher used to come and explain many more things. Now, teacher passive. Teacher doesn't do that to Ghogre style. Wag. Students, they prepare themselves slides. Very lovely slides are prepared by them. Today's presentator's name is already here. Who is going to present? Master Sashank Acharya. And topic is pressure. What he is going to present, let's check. Let's welcome on the stage today's presentator, Sashank Acharya. Please, don't hesitate. Don't stand your mind.
Namaskar and good afternoon to you all. Today I am here to present on the topic of pressure. Applications of thirst in our daily life. First is balloon, second is ship and boats, third is hydrometer, fourth is swimming, fifth is sinking and floating, and sixth one and last is submarines. Now I am going to explain about swimming. Swimming activities of humans, fish, and other animals are also the result of the buoyant force exerted on their bodies. The lack of swimming in Europe during the Middle Ages is explained by some authorities as having been caused by a fear that swimming spread infections and caused epidemics. There is some evidence of swimming at seashore resorts of Great Britain in the late 17th century, evidently in conjunction with water therapy. Not until the 19th century, however, did the populate, popularity of swimming as both recreation and sports begin in earnest when the first swimming organization was formed there in 1937. London had 6 indoor pools with diving boards. Swimming in upthrust is also used in swimming while we horizontally go up or go down. If we cannot, there is no upthrust if we go vertical horizontally. Here is some figures to show swimming of a person and fish. Another one is sinking and floating. The sinking and floating of a body depends on the imbalance and balance between the gravity of the body and the buoyant force action on it. If these two forces are unbalanced, meaning the gravitational weight of a body is greater than the buoyant force applied to it, the body sinks in the fluid. On the other hand, if the two forces, weight and buoyant force on a boat, are equal, the body floats on the fluid in which it is placed. If there are if the object has less density than the water, then the object will float, and if the object has more density than the object will sink. Here are example of floating. Floating means this. Distinguish sink. Another one is submarines. Submarine, any naval vessel that is capable of propelling itself beneath the water as well as on the water surface. This is a unique capability among warships, and submarines are quite different in design and appearance from surface ships. Submarines first became a major factor in naval warfare during World War, when Germany employed them to destroy surface merchant vessels. In such attacks, submarines used their primary weapon, a self-propelled underwater missile known as a torpedo. Submarines played a similar role on a large scale in World War II in both the Atlantic by Germany and Pacific by the United States. In the 1960s, the nuclear-powered submarine capable of remaining underwater for months at a time and of firing long-range nuclear missiles without surfacing became an important strategic weapon platform armed with torpedoes as well as anti-ship and anti-submarine missiles. The nuclear attack submarine has also become a key element of naval warfare. As we all know, this submarine is used for going underneath the water without any harms or hesitation. Many people have also found new things from underwater by help of the submarines. Submarines are also used in World War II. Self-propelled missile known as a submarine as a weapon also was used in World War II, and its name was torpedo. And in the World War II, Atlantic and the Pacific as both used submarine. Atlantic used that submarine. Germany and United States. Germany used that submarines in Atlantic, and United States used it in Pacific. There is a figure of submarine also. Basic parts of ballistic missile submarine. Another is Archimedes principle. We have studied that when a body is partially or completely immersed in a liquid, it loses its weight due to upthrust or buoyant force applied to it. Archimedes principle tells us about the amount of buoyant force applied to a body when it is partially or completely submerged in a fluid. This principle is also applicable to both gases and liquid. As you also know that Archimedes found this law when he was bathing. This law was discovered by Greek scientist Archimedes, that the upthrust of buoyant force on a body inside a fluid is determined by the amount of fluid displaced by the body. If a body can displace more fluid, more upthrust is applied to the body. Verification of Archimedes principle. Here is a figure of spring balance in which these two are solid. Principle or law of flotation. This is the law of flotation or the principle of Archimedes. The case one of the Archimedes principle is when the density of a body is greater than the density of the liquid in which the body is kept, the value of the weight of the body is greater than the upthrust exerted on it. Like I said earlier, the body will sink if the density of the body is greater than the fluid or water or any liquid. Solutions. As a result, the body sinks in the liquid. In this case, weights of the body, the weight of a first body is more than the weight of the liquid displaced. And here is also a formula derived by it. Thus, if the density of a body is greater than the density of the liquid, the body will sink in the liquid. Case 2. When the density of a body is equal to the density of the liquid in which the body is kept, the value of the weight of the body and upthrust exerted on the body are equal. That means if the density of the liquid or of the body is same, then the value of the weight of the body and upthrust exerted on the body are equal. A body floating in a liquid, this egg has also same density, literally equal to the liquid. As a result, the body floats inside the liquid. In this case, the weight of first body is equal to weight of the liquid displaced. And here is the formula derived by it: d1 equals to d2. Thus, a body floats inside the liquid in the density if their densities are equal. Case 3. When the density of a body is lesser than the density of the liquid in which the body is kept, the value of the weight of the body is lesser than the upthrust exerted on it. That means if the body has less density than the water, it will float, and the weight of the body it exerted is and the weight of the body is lesser than the upthrust exerted on it. A body floating in a liquid. As a result, in that case, the body floats, keeping its some parts out the liquid. In this case, weight of the body and the weight of the first body is equal to weight of the liquid displaced. And here is a formula derived by it: d1 b1 equals to d2 b2. In this, density of second body is more than the density of the first body. Thus, a body floats, keeping some parts of it out of the liquid when the density of the second body is lesser than the same density of the liquid in which the body is kept. The principle of floating is in fact a special case of the Archimedes principle. The law of flotation states that the weight of floating body is equal to the weight of the fluid displaced by the body, or weight of the floating body is equal to weight of the displaced fluid. Thank you.
Thank you very much. Oh my God! So I think this is the longest slide made till now, right? 26 slides means it's not a joke, right? For one day's presentation. So very lovely. Who is this? Ini arigato. Naruto. And there is Naruto. Here is Naruto. Is Naruto? Naruto is. No, no, here is given sacred chess. What is this? Application. And Naruto means what does it do? Salute.
No, it is the same like the animation.
Oh, cartoon. This is cartoon. Right? What does it do? That's a cartoon. Okay, okay, children. So let me go to the book's content and then discuss over here. Hey? Class 10. Class 10. So when we didn't start this presentation, it was a different class. Now our class will be like this. Hey? And if you have got any idea to make it more better, you suggest me. That also can be done. Isn't it? Nowadays, what I have given duty to individual students. Because if you only I call few students, others they will be backwarded. All are equal for me. Yes or no? So it's your interest whether you give your best or least. Children, so today Sashank Acharya he explained about mainly these things applications of upthrust in our daily life. Here we have to make our concept clear that upthrust means any upward force exerted by liquid when a body is immersed in it, either wholly or partially. Not only liquid, by air also. It means fluid. Fluid means the thing that can float. So here is given balance. See this balance. If the hydrogen is filled in it, then they go much higher. Yes or no? Because the density of hydrogen is less and the density of air is more, so it exerts more upthrust to it. But if the balloon is filled with carbon dioxide, then it will not go up. It will go downward because density of carbon dioxide is more than density of air. So it's a matter of floating and sinking. If it remains up or goes up, that is floating. If it goes down, what is it? Sinking. Yes or no? Next one is ships and boats also. Like if the ships, boats, they carry less load, they sink less. They can float easily. But if more load is added, then the hull, lower part is called hull, it sinks more. Why does it sink more? Because it has to displace more amount of liquid, fluid. If more fluid is displaced, it experiences more upthrust. Less fluid is displaced, less upthrust. Okay. So while going also, when we jump down in this position, in vertical position, we displace more water or less water. In this way, vertical, less water. That's why upthrust is less. But if we are in horizontal position, more, then upthrust is more. So because of that, we can swim. In swimming, also same thing. Here is given one example of swimming. See, position is like this, right? So more area, more volume displaced. But like this, in this position, area is less volume of water is displaced, and upthrust is less. Could you remember the factors affecting upthrust? Upthrust equals to B dg. More volume. In this case, less volume. In this case, more volume. Tell me, is it easier to swim in fresh water or in salty water? Why salty water? Yeah, density of salty water is more. That's why it's quite easy to swim. Yeah. So in swimming pool, you have seen the color is blue color, right? Why is blue? They use one salt, copper sulfate. What do they use? Copper sulfate. But one thing we have to keep in mind: after swimming, you must not forget to wash your body with soap. Otherwise, the skin comes out. I have noticed. Last time we had gone to bath in one swimming pool in Toka side. We bath 2 times, 3 times, 4 times. Afterwards, we thought, oh, so lovely this and that came out. Then back side of our skin, it was coming. Like that. Because that is chemical, no? It attacked our skin. So we must not do. Swimming also same thing. And next one, what is it? Oh, this is also very interesting. And hydrometer. What is hydrometer? Used to measure the density of liquid. A special type of hydrometer is lactometer. What does it do? Yeah. So this portion is hydrometer. We have to remember. This one, this is hydrometer. This base is of it, heavier one, and this longer neck is lighter, and it is graduated. Graduated means it contains the ruler or scale. Ruler or scale. If the liquid is having low density, it sinks more. If the liquid is having more density, it sinks less. It goes upper one. Like the farmer who milks the cow, that milk is the purest one. Yes or no? Isn't that purest one? And if that milk is brought to the market by same farmer, I think it won't be that much pure also, because everybody wants to profit, get profit. No? So he will add some water and decrease it, right? Yeah, it can be checked as well. Uh, Here, this sinking and floating also based on upthrust. Children, sinking and floating is also based on upthrust. If upthrust is less than the weight of the body, remember here what I said? Upthrust, upward force is less than upthrust or upward force is less than weight of the body. Then what happens to it? Sinks. If upthrust is more than weight, then it floats. Main thing is like that. Sinking and floating is also connected with it, right? And Sashank, he told three experiments. What did he say? Three experiments. One experiment is like this. Here is one container. Here also another container. How many containers are here? Three containers. And what do the containers contain? Fluid. Let's say liquid, right? Any liquid, and the easiest liquid is water, or is easily available, right? So children, don't talk now. So here in these three liquids, three containers. Suppose container A, container B, container C. Three containers are here. One object is placed. The object lies at the bottom. Where has it gone? At the bottom. Another body, it remains inside the liquid. Another remains just upper one. Okay. What about this object? Is it floating or sinking? Sinking. This object floating. This object floating. But what is the condition of these two floating? I'll tell you. This object is sinking means its density of object is more than density of liquid. Density of object is more than density of liquid. Okay, if density is more, then the liquid it will sink, right? Suppose you take one iron ball, put in water. What will happen? Sink. Why? The density of iron is more. Density of water is less. That's why it sinks. But interesting. Iron nail, it is made up of iron. Sheep, made up of iron and other things. Sheep is much more heavier. I think one ship can carry more than 3,000, 4,000 people. They can go. But does it sink? Why doesn't it sink? Then we will discuss that thing also. Right? So here we are discussing about density. If density of object is more than density of liquid, it sinks. In this case, it is floating inside, yes? So, if density of object is equal to density of liquid, if their density is equal, then it may float anywhere. It may float anywhere, right? Please remember. But in this case, density of object is less than density of liquid. If so, it completely floats. Is it floating or not? Right? So, in this case, children, in this case, the body experiences less of thrust than its weight. Yes or no? Here, of thrust is equal to its weight. Of thrust is more than its weight. These things you have to remember. Understood or not? Now, I ask one question. An iron nail made up of iron sinks in water, but a ship made up of iron floats in water. Why?
Because sleep displays water.
Because both are made up of iron, no? Here, this sinking and floating is based on amount of displaced water also. Amount of, if the weight of body is more than weight of liquid displaced, weight of liquid displaced, then it will sink. Weight of body is equal to weight of liquid at that time. What happens to the body? Floats. Okay. So the ship, which is made up of iron, floats easily on water because it displaces water equal to its weight. Out of you all, how many you know how to swim? How many? Susan, you know others? The other they don't know. Means if you are thrown in water, then who can survive? The person who can swim. Because he displaces water equal to its weight, he float and come out. Rest of the just bringing some water and there only Ramnam Tate. Already he said about this candidate, what is his name? Archimedes principle. Actually, it is said that Archimedes was a Roman soldier. Who was he? Roman soldier. So, but he was more creative one, that's why he became scientist. In his time, there was bathtub in his toilet. What are there? Bathtub. In my house, there is no bathtub. I don't know in your house, is there bathtub or not? Who has got bathtub in toilet? Simres. Do you have Simres? How do you know? Oh, that means this beer thought one bata is bathtub. Yes. That is also okay. Yes or no? Otherwise, that bathtub is different, right? In that, in Chitlang, bata is bathtub. Okay, very good.
No, there is some swimming pool also.
Where?
In natural.
No, that is okay, but we are talking about bathtub. We are talking about bathtub, no. No, last time I had gone to Pokhara and I got chance to stay in 3-star hotel. There was bathtub, yeah, so lovely bathtub was there. But we had gone during winter season in Mamsir. What's the use of that bathtub? Was there any use? But if needed, we could use water in the bathtub. When he was inside, the level of water was raised to a little bit upper height. When he came out, came down, fell down, right? So he propounded law afterwards. What was that law called? Archimedes principle. So what does Archimedes principle state? Is there any statement of Archimedes principle? Where is it?
Archimedes principle.
Yes. Here is Archimedes principle. Will you read what is given there? When a body is immersed partially or only some part or wholly or completely in a liquid, it experiences an upthrust which is equal to the weight of the liquid displaced by it. For example, one object is there. Its weight in air is how much Newton? 30 Newton. When you keep in water, will its weight be same or different? Weight will be, let's say, how much Newton? 20 Newton. And what happened to 10 Newton? 10 Newton liquid is displaced. 10 Newton liquid is displaced, and that is equal to Upthrust. Now let me make you clear. Sashank Acharya, his weight is 600 Newton. How much Newton? He jumps in swimming pool. He feels heavy or lighter? He feels lighter, means his weight becomes a bit lighter. Now his weight is 520 Newton. In air, how much Newton? 600. In water, how much Newton? Where has 80 Newton gone? His weight is decreased because of upthrust. That means, what is the upthrust? 80 Newton. How much water is it displacing? 18 Newton. How much is the difference? That much water is displaced. Is that clear or not? So, upthrust is equal to always weight of displaced liquid. Upthrust equals to weight of displaced liquid. So, this type of diagram must be drawn. Please look at here. Here is one activity. Is there one activity? So, this activity we have to do this Friday. Friday, let's go and do this experiment, right? So, Archimedes principle. For Archimedes principle, we need one spring balance and any solid is needed. One thread also is needed. We can measure its weight. Weight in air. Let's say weight in air is 90 Newton. How much? Afterwards, take one. This device is called Eureka can. What do you call it? Because look at here. Here is one part. If there is a little bit displacement of water, it comes out. No. So this is called Eureka can. But we must not forget to fill water up to its spout. What do you call? Spout. And when we insert that solid here, then does it displace some water or not? And that displaced water, where did it go? Slowly it will go and join here. It will mix here. Then suppose its weight was how much Newton in here? 19. 90. How much is here? 80. Now 10 Newton lift displace or not? Means 90 minus 18 means upthrust is how much? 10 Newton. And how much water will be collected here?
10 Newton.
Water also will be collected here? 10 Newton. That's why simply he says upthrust is always equal to weight of displaced liquid. Upthrust is always equal to weight of displaced liquid. Pujana went for swimming. Her weight in air is 90 Newton. Oh, so light color. How many Newton? 19 Newton. And not kg also. 19 Newton, 9 kg. Not this Pujana, another Pujana is there. No, some are small Pujana also. Pujana cartoon. Okay. Weight in air, 90 Newton. But when she jumped in water and she measured, her weight is how much? 50 Newton. How much Newton? 50. 50. So what the difference in weight? So that 40 Newton is upthrust. And how much water is displaced? 40 Newton. You have to make your concept clear like this. So here is given something. What is here? Weight of the stone in air is W1. Weight of the stone in water, W2. Loss in weight of the stone in water, W2 minus W1. Wrong. It should be W1 minus W2. It became a mistake. W1 minus W2. Weight of the empty beaker, W3, let's say. And weight of the beaker in the displaced water, W4. Weight of displaced water, how much? W4 minus W3. And it comes like this. So, upthrust. So, what is the conclusion? Upthrust equals to weight of displaced liquid or fluid. W equals to W2. So, these are the things. And I have already said about this sinking and floating, right? These are the things. So, once again, will you read this portion and make concept clear? So, read what the teacher has said, what your friend has said, and set in mind. Afterwards, you can make a note. Understood or not? First, read once again these things. So, try to understand the matter. Then you can write. Is that okay? Please.